Hi. Using the same time series as we had before, we're going to use single exponential smoothing to make forecasts. Our time series includes 5 past time periods, 1, 2, 3, 4, 5, and our actual data values or our y variable is 450, 495, 518, 563, and 584. If you're using the Management Scientist textbook, which is by Anderson.wmv, the formula that they give us is the forecast for the next time period, t plus 1, is equal to alpha, which is a smoothing constant, and it should be a number between 0 and 1, times the actual value from the period that you're in, plus, and then you take 1 minus alpha, and you multiply it by the forecast from the time period that you're in. And for this model, you should always have an initial forecast to start off our series. Let's use alpha equal to 0.3 for this analysis. And you should always have, and these are forecasts that we are generating in this column. And we're going to use alpha equal to 0.3. Alpha is really a weight that we assign to our calculation. As I said, you need to have a starting forecast value when you use single exponential smoothing. Let's assume that the 450 that we have as our actual for time period 1 is also our forecast for that same time period. So now I have actual at time period 1 and forecast for time period 1. So to make forecast for time period 2, this is how I compute it. I take my alpha, which is 0.3 for this problem, multiplied by actual for the time period that I'm in. Right now, I'm in time period 1, and I'm making the forecast for time period 2. So I'll take alpha times the forecast, times the actual value for the time period that I'm in, which would be 450, plus 1 minus alpha, 1 minus 0.3 is 0.7, times the forecast for that time period, which is 450. And of course, if you go through the math, you'll get this to be 450. So now I have forecast for time period 2 as 450, and my actual is 495. So now using these two, I'll be ready to make the forecast for the next time period, just like this formula suggests. You use the actual and the forecast for any given time period to make the forecast for the next time period, t plus 1. So F3, forecast for time period 3, will use actual and forecast from the previous time period. 0.3 times 495 plus 0.7 times 450. And if you go through that math, you're going to get 463.5. Now, again, we're going to use the 518 and the 463.5 to forecast time 4. So we'll get F4, forecast for time 4, is 0.3 times actual plus 0.7, 1 minus alpha, times forecast from time period past time period 3. 463.5. And that number should be 479.85. And we'll do the next one. F5 is 0.3 times 563 plus 0.7 times 479.85, and that gives me 504.8. And now I can use that information, the actual and the forecast, from time period 5 to make a forecast for time period 6. So even though I don't know, or it's a question mark, what the actual will be in year 6, but I can estimate or forecast sales. And that will be 0.3 times 584 plus 0.7 times 504.8. And that number will be 522.56. 522.56. And again, using these actuals and these forecasts, you can do error analysis. In this example, we've used alpha of 0.3. Alpha can range anywhere from 0 to 1. It's like 0% weight or 100% weight placed on our analysis. And so you can experiment with this and go through the math and see what it will be for alpha of 0. Let's say 5 or 0.6 or 0.9 or 4.8 or whatever. And then you can go through a small problem like this, do several of the calculations, and then check your work with POM/QM and see whether you're coming up with the right analysis. Thank you. I hope you found this helpful. This is Dr. Shafai.